Do you feel the vibes?
Okay, so in section 3, we're going to learn how to solve trigonometric equations, right? So, okay. So what does it mean, like, to solve an equation? Okay, so if I have, for example, like 3x minus 6 is equal to 0, okay? Or I'm sorry, if I have like 3x minus 1 is equal to 4, okay? One thing I can do is I can graph 3x minus 1, okay, like this. And then, so here is 4. And I could see what is the x value where the graph equals to 4. Okay, that's really what I'm doing. In trig, same thing. If I have an equation like this, cosine of x is equal to a half. Do you see here this blue is the graph of a cosine function? And then the red dotted line is equal to a half. So all of the points where they meet is where cosine of x equals to a half. So you can see cosine of x is a half at pi over 3. But also, if from pi over 3, if I go over 2 pi, and also if from pi over 3, I go over 2 pi this way. So every time from pi over 3, I go over 2 pi, over 2 pi, over 2 pi. Cosine is also equal to a half at 5 pi over 3. But also when I go over by 2 pi or this way by 2 pi. Okay. So the way in which we write that is we say cosine is x is equal to pi over 3 and 5 pi over 3 if we're looking just from 0 to 2 pi. Or if we're looking at the whole darn number line, we say it's pi over 3 plus 2n pi, 5 pi over 3 plus 2n pi. What does n pi mean? It's because I can go plus 2 pi, then plus 2 pi twice, then plus 2 pi 3 times, right? So n times I can go plus 2 pi, plus 2 pi, plus 2 pi. So now that we've got that down, let's take a look at how do we solve these? Okay, so look at this one. I have sine of x is equal to a half. So for these, we're going to use two things in conjunction with each other. One thing we're going to use is these lovely triangles that we all love so much. Yeah? So remember for the pi over 3, what's the vertical side? The other one. I'm sorry. I wrote these wrong. This is 3 and this is 6. For the pi over 6, the first one, this is a half. This is root 3 over 2. What about for the pi over 3? So this is root 3 over 2 this time, and this is a half, right? And then this is 1 over root 2, 1 over root 2. We're going to use this in conjunction with our lovely unit circle. Okay? All right. So here's what we're going to do. Let me just do this. So sine of x is equal to a half. First of all, let's figure out which angle is it. Is it the pi over 6 or the pi over 3? For which pi over 6? For the pi over 6, the vertical, the sine, is 1/2. So we say x equals pi over 6. But now we might have to come up with two answers. So let's go on the unit circle. We want sine of x to be positive a half, right? We know that sine of x is equal to positive in these two quadrants. So if I have pi over 6 here, what's the equivalent of pi over 6 there? So remember, 5 pi over 6. And those two together are my answers. Okay. Here, let's first solve for cosine. So divide by 2, divide by 2. Cosine of x is equal to negative 1 over 2. So now first decide, for what angles are we looking at? 1/2, cosine of 1/2. Which angle is that? Is it the pi over 6 or the pi over 3? So now cosine is not the vertical. Cosine is the horizontal. So for which one of these is the cosine equal to 1/2? Pi over 3. Okay? Now, so I want the pi over 3's. However, we want it to be negative. Cosine is negative here and here. All right? What is pi over 3 in these two quadrants? 2 pi over 3 and 4 pi over 3. Okay, now. Okay, now we're going to do another one. Okay, starting with these.
Oh, and the answer's not
If
because that's
right. So starting with these next ones, I want participation from everybody. That means if you want to give out an answer, you have to wait for me to call on you. Raise your hand, okay? Let's do this one. Oh, now I have 2 sine of x is plus or minus root 3. First, I divide by 2. So sine of x is plus or minus root 3 over 2. When I have plus or minus, I have two equations. Sine of x is root 3 over 2. Sine of x is negative root 3 over 2. Now, without calling out the answer, first let's think about which of the triangles are we going to use for sine of x, the vertical one, to be root 3 over 2. Which one? Pi over 3. Now, let's take a look. For the first one, we want sine to be positive. That's these two quadrants. So one of them is pi over 3. And so now in the second quadrant, we need to figure out which one it is. And I want hands. In the second quadrant, which one is the equivalent of pi over 3? 1 over. So, okay, so you have to 1 over the other way. So you have to tell 1 pi over 3. 2 pi over 3 is this one. You missed a 2. Okay, so it's 1 pi over 3. 2 pi over 3 for this one. Now, for the negative, it's these two quadrants. So x equals, okay, so Daniel, let's go with it. So 1 pi over 3, 2 pi over 3. This one would be how many pi over 3? You were right before. 4 pi over 3. And then this one would be 5 pi over 3. So the answer is really, not really, the answer is all 4 of these. This one has 4 answers. I know. Okay? Yeah. Now, okay. Here we go. Okay, this one. We have to get the cosines alone, right? So first I need to subtract 3 cosine x. So what I have now is 5 cosine x minus 3 cosine x. 2 cosine x equals root 3. I'm going to divide by 2. Divide by 2. So now I have cosine x equals root 3 over 2. Okay, the line of reasoning is this. First you think cosine is the horizontal one. Then we're going to go to our triangles and we're going to figure out which one of these is going to give me the cosine to be equal to, how much was it? Root 3 over 2. Which one? Pi over 6 it is. So x equals pi over 6. But now, let's see which two answers we want. We want cosine to be positive. Okay? So it's this one and this one. Pi over 6 here. Right? And then it's 5 pi over 6, 7 pi over 6. Maddie, what is it over here? 11 pi over 6. So it's pi over 6, 11 pi over 6. Remember, you have to increase the coefficient of the 6's and use only the ones where it doesn't cancel. Okay? Okay. So, what do you guys suggest I do here first? Add 4. So, 3 tangent squared x equals to 1. Now I need tangent alone. Robbie, what do you suggest I do now? Divide by 3, so tangent squared x is equal to 1 over 3. Now, take a square root of both sides. So tangent of x is plus or minus root 1 over root 3. Root 1 is just 1, so we don't have to write it. So basically what we have here is, we have 2. Tangent of x equal to 1 over root 3. Tangent of x equal to negative 1 over root 3. Okay, now, this one is tangent. So it's vertical over horizontal. You have to go to your triangles and you have to say for which one of them is vertical over horizontal going to give me 1 over root 3. Okay, last time you gave me an answer without raising my hand. Pi over 6. Okay, right? Okay, pi over 6. So now, okay, so we're looking at the pi over 6's. So let's look on the unit circle. Tangent is positive here and here. So this one is pi over 6. And now we want the equivalent here. Okay, so, okay, Rowan, I'm going to go to you. What would be the equivalent of pi over 6 here? 7 pi over 6, good. So I have pi over 6, 7 pi over 6. Now I need the two negative quadrants, here and here. Positive. 5 pi over 6, 11 pi over 6. All right? They're all positive numbers, but they're in the negative quadrants. No, that's the square. So remember, if you take a square root, it'll be root 1 over root 3. You're thinking if we square it, different things. All right. Okay? All right, so let's do a couple more. Now here, I know everybody's first instinct is going to be divide everything by sign, but don't do that, because then you get rid of the problem, right? We're going to bring everything to the same side. Is that okay? Right? So bring the root 3 sine x over to this side and do negative root 3 sine x. No, 2 sine x. So now, do you see how I have a subtraction here? I have 2 terms. 1, 2. What's common in both of them? Sine is common in both of them. What if I factor out sine of x? What do I have left from here? 2 cosine x minus root 3. We were doing this like last lesson. Okay, so here's what we're going to do now. Something times something equals 0. So we split it. sine x equals 0, and 2 cosine x minus root 3 equals 0. All right? So where is sine equal to 0? It's not going to be in one of the triangles. You don't have 0 sides. So then it's got to be 0 degrees. Where else? Here as well. 180. 0 and pi, but we always go in radian, right? 0 and pi. Huh? Yeah. And then this one, what am I going to do? Add root 3. So 2 cosine x equals root 3. Cosine x is root 3 over 2. Okay, Kieran, tell me, which one of these triangles has cosine root 3 over 2? Pi over 6. And I want it in the positive quadrants, right? So it's pi over 6 and 11 pi over 6. Huh? Yeah, so x is 0, pi over 6, 11 pi over 6. 4 answers. Yeah. Huh? Yeah. Yeah, so we're going to factor out a sine x first. So, and we're going to get 2 sine x plus what? 1. Because if you take out a sine x, it means you're dividing each term by a sine x. So from here I get sine x left, from here I get 1 left. Well, you factor it out. It was yeah. Of course it makes sense. It's math. So if sine of x is equal to 0, again, x is 0 and pi. Here I have 2 sine x plus 1 equal to 0. 2 sine x equals negative 1. Sine x equals negative 1 over 2. So now I want the triangle for which sine is a half. So Ari, help me out with that one. For which one is the vertical side, the sine equal to a half? So pi over 6, right? Okay, but now look, guys, I need it to be negative. Negative. It's got to be in these negative quadrants. So it's the pi over 6's, right? So this is 7 pi over 6, 11 pi over 6. So my answers are these two here, these two there. Okay, here, what can I factor out? A cosine x. I know. Oh, what? I did that so fast. Should I slow down? So I factor out a cosine x. From here, I'm left with a cosine x. From here, minus 1. So cosine x, equals 0. Cosine x minus 1 equals 0. Okay, now, where's cosine equal to 0? At pi over 2 and 3 pi over 2. Right? Because, why? Because at those, it's 0, comma 1 and 0, comma negative 1, and the x coordinate has to be 0 for the cosine to be 0. Here, cosine of x is equal to 1. Okay, cosine is the horizontal side. Do I have a triangle with the horizontal side equal to 1? I do not. So it's got to be one of these quadrantals again. But look at these two. 1, 0, negative 1, 0. For which one is cosine 1? The x value. Just 0. Right? So we're just looking at the x values, and it's these three that we want. So x equals 0 and these two. This is a nice one. And we got two more. I love math. Could you tell? Huh? Well, we can't factor anything out right now. First, we have to bring everything to the same side and set it equal to 0. So let's do that. So cosine x, tangent x, minus root 3 cosine x is equal to 0. Now, I factor out a cosine x. So Aton, from this term, what do I have left over? Tangent x. If you have cosine times tangent, you take out the cosine, you have tangent. So remember, factoring out is the same as dividing by the thing you're factoring out. Right? So here I have minus root 3 is equal to 0. So cosine x equals 0. I know. Tangent x minus root 3 equal to 0. Where did we say cosine was equal to 0? Pi over 2 and 3 pi over 2. Okay, now, this one. Let's think about this before we answer. Tangent of x is equal to root 3. We're going to go over here. Tangent is opposite over adjacent, vertical over horizontal. One of these things, when I do vertical over horizontal, Rowan, I'm looking at you, is going to give me a root 3. Which one? So the vertical over the horizontal needs to be root 3. Which one do you think? That is the one, right? Because these will cancel, so you'll get pi over 3. Yay, pi over 3. Love me that angle, pi over 3. But now, I want it in the positive quadrants. So if it's pi over 3 here, Robbie, do you know how much it is here? It is 4 pi over 3. Yay! Okay, what do we do here? Okay, so why don't we factor out a cosecant x? So look, guys. When you factor something out, it's just like dividing each of the terms by the thing you're factoring out. So in the first one, I get tangent squared x minus 1. I mean, that's one of the things, yeah. So, look at you guys. Yes, but we don't have to do that. That is a thing. Okay, but look. Cosecant x equals 0. Tangent squared x minus 1 equals 0. Okay, where is cosecant equal to 0? What's cosecant like? Yeah, but see with the zeros, huh? It's 1 over sine. Yes, so where would it be 0? Where is cosecant equal to 0? Actually, cosecant is not 0. I've written this down. Let's just cross that one out. How about this one? Tangent squared x is equal to 1. Square root. Tangent of x is equal to what? Just 1. Plus or minus 1, yeah. So, tangent of x is equal to 1. Tangent of x is equal to negative 1. Go back to your triangles. Let's see. Pi over 4. Why? Right. This over this has to be 1. That's got to be the pi over 4. So, it's positive 1 here and here. So pi over 4 and 5 pi over 4. It's negative here and here. What are these? 3 pi over 4 and... Oh, I wrote these wrong. No, I didn't. No, 7 pi over 4. Oh my gosh, Miss Malikian. This is what happens when I get hungry. Okay? And there you have it. That's this lesson.
Press start.